Okay. તો પહેલા આપણે રિફ્લેક્શન બાય સ્ફેરિકલ સરફેસીસ એ બધું સ્ટડી કર્યું. નાઉ રિફ્રેક્શન બાય સ્ફેરિકલ સરફેસીસ. ઓકે, અને આ રિફ્રેક્શનનો સ્ટડી કરીને પછી આપણે લેન્સ ઉપર જઈશું હવે. ઓકે, સી સપોઝ we have a spherically curved surface as shown in the figure. The refractive index of this medium, which one is the spherically curved one, that is N2, and for this first medium from which the ray entered to this spherical surfaced medium. So for that first medium, the refractive index is N1, and here N1 is less than N2. Now, for spherically curved surface, the geometric center of the surface, that is called optical center. જે આપણે મિરરમાં પોલ કહેતા હતા એમાં અહીંયા આગળ વર્ડ યુઝ થાય છે optical center. Okay, and now here consider the imaginary axis passing through the optical center and the center of curvature of this spherical surface, and that is the principal axis. Study કરી ગયા છીએ, right? Now, suppose here we consider a point-like object on the principal axis. Then let's first discuss this thing with the help of ray diagram, how and where the image of this point-like object will be formed. So, prepare the ray diagram. Take one ray from this point-like object along the principal axis, this ray. Now consider another ray which incident on the spherical surface at a point N. You can take any point arbitrarily. Okay. Now, if we prepare here the line element Cn, then Cn, that is the radius of curvature. So at N, that will be the normal. So we can say for this incident ray, this I is the angle of incidence. Now ray is propagating from optically rarer to optically denser medium, so it will be deviated towards the normal. એટલે આ રે N પાસેથી જ્યારે આ optically denser medium માં enter થશે એટલે આ NC જે line element છે, that is the normal at N. તો એની તરફ વાંકું વળશે. એટલે એ બાજુએ મેં જો એને વાંકું વાળીને આગળ propagate કર્યું. Then this refracted ray and the ray which one is propagating on the principal axis, એ deviate નહીં થાય. કારણ કે એ તો અહીંયા M પાસે normally incident થવાનું છે. એટલે એ એની એ જ directionમાં propagate થશે. So the point where these two rays intersect, there the image will be formed. એટલે point like object O નું image અહીંયા point like I પાસે મળશે આપણને. Clear? Okay. Now, here the distance between optical center and object, that is object distance U. This distance M to C, that is the radius of curvature, that is capital R. Image is formed at I, so distance M, I, that is the image distance, that is V. Angle of incidence here at point N on the spherical surface, that is I, and angle of refraction, that is R. Now consider arbitrarily here the angle between incident ray and principal axis, that is θ1, angle between the normal at the point of incidence and the principal axis, that is θ2, then the angle between refracted ray and principal axis, that is theta 3, as shown in the figure. Clear to all of you? Now, here we consider paraxial rays. It implies that rays are very close to principal axis. So angles will be very small. And now if we draw the normal on the principal axis from this point N, then we can take that normal point of incidence here and M. Both are one of the same. Okay. Now consider here tan theta 1. So if we take tan theta 1, then tan theta 1, that is opposite upon adjacent. Opposite, that is NM, and adjacent, that is MO. But angle is very small. So we can write tan theta 1, that is nearly equal to theta 1. So tan theta 1 is nearly equal to theta 1, that is equal to NM upon MO. Similarly, take tan theta 2 here. So again, it is very small. So we can write that is nearly equal to theta 2, that is opposite NM upon MC. Then take tan theta 3. So tan theta 3, that is nearly equal to theta 3, that is again opposite NM upon MI. Now, see here. Consider the triangle NOC, this triangle. Now see the figure for this particular triangle NOC. Theta 1 and theta 2 are interior angles and I, that is exterior one. So we can write for triangle NOC, I, that is equal to theta 1 plus theta 2. But theta 1 is NM upon MO and theta 2 is NM upon MC. Substitute these two values. Now keep this one as it is. Then after consider the triangle NCI. This one, NCI, this one. So for that, theta 3 and R are internal. And this theta 2 is exterior one. So we can write theta 2, that is equal to R plus theta 3. So we can write R, that is theta 2 minus theta 3, and now substitute the value of theta 2 and theta 3, this one here. Now keep this one as it is. Now apply Snell's law at point N. Then we can write N1 sine I, that is equal to N2 sine R. But I and R are very small, so we can write sine I, that is equal to I, and sine R, that is equal to R. Now, in this equation, substitute the value of I, that is NM upon MO plus NM upon MC. તો અહીંયા આપણે substitute કરી દીધું એને. N1 as it is. Here N2 as it is, substitute the value of R, that is NM upon MC minus NM upon MI. This one. હવે see, બંને side થી NM common લઈ લો, cancel થઈ જશે. So now we can write N1 upon MO, this N1 upon MC, that is N2 upon MC minus N2 upon MI. So now take this N2 upon MI, this term on left hand side, and this N1 upon MC on right hand side. So you will get N2 upon MI plus N1 upon MO, that is equal to N2 upon MC minus N1 upon MC. Now, here MI, that is V, image distance. Then MO, that is U, object distance is always negative. So we can write here on left hand side N2 by V minus N1 by U. that is equal to N2 minus N1 upon this R. MC that is equal to R. Okay, and R and V both are in the direction of the incident ray. એટલે બંનેને આપણે positive લીધા અહીંયા. Finally, we can write minus N1 by U plus N2 by V that is equal to N2 minus N1 upon R. This equation is the equation for the refraction by spherical surfaces. Clear to all of you?